everyone. In this video, I am going to discuss how to represent a numbers in Verilog. So we will discuss in detail with some suitable examples. So representing a constant values. Constant values can be specified either sized or unsized form. If you want to represent a sized numbers, you need to specify width as well as the radix. We'll see some example. So now, how to represent unsigned numbers in Verilog. So this is the syntax. Here tick, base and values. Here base may be a decimal number system or octal, hexadecimal, binary number system. So see some example, then you will get an idea. 659. So the default radix in Verilog is a decimal number system. No need to specify the radix 10 here. Now here no need to specify the base in the syntax. Now 659, the default radix is the decimal. So it is a valid. If you didn't specify any radix, nothing but it is a decimal number. So now tick H7FF. It is an hexadecimal number. So tick H represent here hexa number, right? So the base of this hexadecimal number is H. So tick H7FF. Now tick O7460. So here O represent the octal number. So tick O7460. So it is an octal number. So now another number we can 4AF. So he didn't specify any radix here. Actually, so the default radix in Verilog is a decimal. So we didn't specify. But the AF is not in decimal number system. So it is an illegal. We cannot represent like this. If you want to represent this 4AF, then tick H4AF into represent. So it is a decimal number system, default number system in the Verilog. So AF is not there in the decimal. So we get an error. So same way we can see how to represent the size numbers in Verilog. So now this is the syntax. Here size, tick, base, value. So this is the size we need to represent only in binary. Okay, even irrespective of number system like binary, octal, hexadecimal, we need to represent this size in only in binary form. Like how many bits we require to represent that a given number. So size, tick, base and value. So now if you see 4 tick B, it is a binary number. We are using 4 bits to represent this number. So 4 tick B 1001. It is a 4-bit binary number. So another example, 5 tick D3. Here 5 indicate the number of bits required to represent this given decimal number 3. So we can say 5-bit decimal number. So 5 bits here binary in the binary. So another example, 3 tick B 01X. So now it is a binary number. So the B indicate is a binary number. We required 3 bits. Okay. We are using 3 bits to represent this number. So 3-bit binary number. So another example, 12 tick H1X question mark. Question mark means like a Z. So here we use 12 bits to represent the given hexadecimal number 1X and question mark. So we can represent like this also, like same way. So 12-bit means like tick B. So 1 means 0001. So we required 4 bits to represent hexadecimal digit. So now 1001 X 4X and question mark mean all 4 Zs. So another example, 32 tick H12AB F001. So this underscore for to differentiate, like nothing else, right? If you see, if you write 212AB underscore F00, all are like same as a 12AB F001. For user friendly, okay, we are writing this underscore. We can ignore that. Okay, the tool will ignore this underscore. Now see here the radix, here base radix specifications are D, H, O, B. So these are the letters we use to represent a decimal, hexadecimal, octal, binary respectively. So that there may be small or capital alphabet like D, H, O, B. By default, constants are unsigned. So in Verilog, the default are unsigned and will be extended with zeros on the left. So if the higher order bit is X or Z, then extended bit will be X or Z2. So now we'll see some example how to represent these numbers, right? Now for example, if you consider, so by default constants are unsigned and will be extended with zeros on left. And if higher order bit is X or Z, then extended bit will be X or Z. So we'll see some example. For example, if I write like 16BZ. So we can represent like this. This also, it is also equal as 16b. So 16 jets. We can write 16 jet. Now see, for example, if you take another example, 8 tick b 0x. So now here MSB is 0. So we can extend like 8 tick b. So 0, 0, 0, 0. Like we can extend. So now this 0 we can extend it like this. So if I write 8 tick b x 0, for example, if I write like this, now I can extend 8 tick b. This x will be extended like this. We write this 0 and this x will be extended 7 times. Now if I write 8 tick b 1 0, so I can write this is a 8 tick b. So just I can write 1 0 only. We never extend this 1. So we extended the x, or we extended 0, or we extended z. Okay. Now see here, if higher order bit is x or z, then extended bit will be x or 0. If it is 0 also we can extend 0, but if it is 1, we won't extend, just will append zeros. Now if you write, if for example 8 tick b z0, if you write, so we can write 8 tick b like we can write z also, we can extend, right? So for example, if I write 8 tick b 0 z0, we will extend this 8 tick b 0 0 0 0 and 0 0 z0 like this. This 0 will extend. So now that is the meaning here. So now if higher order bit is x or z, then extended bit will be x or z2. If it is 0, then we'll extend 0. I hope you understand this example. So we'll see some example how to represent these numbers in Verilog. Now see, till now we discussed only unsigned numbers, how to represent unsigned numbers in a Verilog. So we also used signed numbers in many ways, right? So now here this single character s will be used to represent or to indicate a signed number. So here just we'll use this sign, this s to indicate the given number is a signed numbers. S does not make number is negative. Just we are saying that the given number is a negative. Don't think that if we use s, so it make that given number is a negative. So to represent negative, to make negative numbers, so we'll use minus sign. So simply s indicate the number is signed. Okay, s does not make a number negative. Don't think that if we keep s in the number, then it make it negative. No, just it represent the given number is negative. That may be positive also. Based on the sign bit, we will decide whether it is positive or negative. But if you want to represent numbers in negative, then you will use this minus sign. So we will see in this example. So simply here 8 tick d minus 6. It is an illegal. We can't use like this. Okay, we cannot represent negative numbers in Verilog like this. So sign bit, that sign should be so before this size. So this is an illegal. So for example, I want to represent minus 6. So I can write minus 8 tick d6. This defines the 2's complement of 6. So here we are using 8 bit to represent this 2's complement number 6. Clear? So we can write like minus 8 tick d6. That is the equivalent representation. So now if you see in this example, 4 tick shf. So we know that this 4 is the size. Clear? Tick s means it indicates the number is sign number. So which this is a hexadecimal number system, and f. So we write just this is equivalent to minus 4 tick h1 or minus 1. So how, right? See, for example, if you see now, for example, I'll explain simple concept, right? It's for example, what is the here? How do I write? 4 tick shf. So we know that f means like simply we can write so all ones. So now it is a hexadecimal number and required 4 bits. That too it indicates sign number. So we can write 1 1 1 1. So we required 4 bits. So it is a 2's complement number. So what is the decimal equivalent value? So now we convert into 2's complement. Okay. So 1 0 0 0. This is a 2's complement of given 1 1 1 1. So now it is a here 1. So it is a minus 1. How do we do that? So for simply we can write here, see 1 1 1. So convert into 1's complement 0 0 0 0. Add 1 then this is the 2's complement representation for given number. So here 1 is there, so it is a negative number, so minus 1. So now this equivalent to minus 1. So decimal minus 1. I hope you understood this is clear. Now another example, 4 tick SD15. Both are same here also. Now it is a decimal number system. So here this is the hexadecimal, this is a decimal, both are same. So in decimal 15. But how many bits we required here? 4 bits. Clear? So now same way we can represent. So this we can write minus 4 SD15. So now we can write in binary. So we are using 4 bits to represent this decimal 15, the two signed number. So we are converting into, okay, 1's complement, then we'll add 1. Clear? 0 0 0 1. So now what is this? It is the minus 1 actually. Here minus, this is a minus 1. But what we'll use? Already we use minus 4. So minus of minus we can represent as a 1. So now this is plus 1. So this is minus 1. I hope you understand. Yes, sir? Right. Now here this S indicate only the given number is a signed number. Don't think that this S make it the number is negative. So now we'll see another example here. So by this example, okay, I'll explain. So here signed number display. Just I'll declare 3 signals, right? Signed register 7 down to 0 and 8-bit signed register, and also one more integer. That too we know that the default width is 32-bit. So I can declare as a 32-bit signed integer, and one more a real number, signed real number. So always anyway that's a real number is a signed one. So just I declare 3 variables of register, integer, real type, that to signed, right? Now see initial, begin. So just I'm initializing some values to this, right? So now here minus 8 tick SD4. So now it is a minus, wait 1 minute. Now minus 4 stored in 8-bit signed register. So now here negative numbers, we use 8 bits to represent this given signed number. That too it is a decimal form 4. Clear? So minus 4. So now and signed integer. So this is a minus 32 tick D2. What is the meaning here? So we are using 32 bits to represent a decimal negative 2. Here minus is there. So we are, so minus 2. To represent minus 2 we'll use 32 bits. So same way minus 3.1415 and floating point sign value. If I display these values along with the decimal as well as the binary. For example, if I display this signed register. So now decimal equivalent is minus 8 tick SD4. Decimal 4. That to negative number minus 4. So how do I represent this minus 4 in binary? Now simply we can use this. So how do I represent this? See. So what is here? For example, I want to represent minus 4. This is a minus 4, yes or no? So I want to represent in binary. How do I represent? Just I'll represent minus 4. How do I represent? So now 1 0 0. This is a 2's complement. So if you find the value, this decimal equivalent is minus 4. But how many bits we required here? 8 bits we are using to represent this number. So we extend this sign bit. So now we extend this sign bit as like this. So this is the in binary to represent minus 4. So we'll get the same answer here. So 4 1s 1 1 0 0. So now here minus 32 D2 decimal 2. So how many bits here? So we are using 32 bits. So for example, how do I represent minus 2 in 2's complement? So 1 0. This is a minus 2. In the decimal, it is a minus 2. It is a 2's complement representation. How do I represent this minus 2 in binary as 32 bits? Just will extend this sign bit like 1 1 1 up to like this will extend. These are the 31 bits and this 0 and plus 1. Total 32 bits we are using to represent this minus 2. Same way like this. For example, now I'll show one. I'll show here this what this S indicate here. This S indicates only the given number is negative. Okay. So don't this S make the number is negative. So we'll see some example. So in this example, same example. For instead of that, if I write minus, if I write instead of minus, if I write plus 8. 8 tick SD4. Okay. Instead of minus 8, I'll write 8 8 tick SD4. So in the earlier case, if I get a minus, what is the value here? We'll get -4. So if I write, for example, 8 tick SD4, what is the value we display? We'll check, right? Now we'll execute this code once. Then we'll run this code. We'll see. What is the answer here? Here, +4. Now, if I write here 8 tick SD4 is the +4. Means this S indicate the given number is negative. But how we get a +4? For example, here. So now 4. How do I represent 4? We know that. Okay. For example, if I write 8 tick SD4, how do I represent this of 4? How many bits are required? 8 bits. So how do I represent 1004? So how many bits are required? 8 bits are used. 8 bits are used to represent this 4. Yes or no? So what is the MSB bit here? 0. Nothing but positive or negative? Positive. So the given number is +4. For example, if I write same example, if it 3 tick SD4, if I write like this, so how many bits are used to represent this 4? 3 bits. Now if I write 100, now tell me, is the S indicate negative number? S here also S indicate negative number, but MSB is 0. S is indicate negative number, nothing but here MSB bit is 1. So now it is a negative or positive? Yes, it is a negative. So we can write -4. Just by changing this width, okay, here +4, we are getting -4. Now we'll execute once. We'll execute once. So same program, I'll take instead of 8, I'll take 4. Clear? Then save and run. We'll see. So here I'll take 4 tick SD4. Okay, sorry, I had to take 3 now. Okay, right, sorry, I had to take 3. Just take 3 and execute. If you take 4S, then you will get a +4 only, because that MSB bit is 0. So now we'll take 3 bits to represent 100. It is the output here. So we got -4. See? Clear? I hope you understood, right? So now if you take 3 tick SD4, we'll get -4. For example, if you take 8 tick SD4, we'll take a +4. Here this S indicate the given number is negative, but based on the MSB bit, it is representation 2's complement form. So based on the MSB bit, then we'll decide. So now how do I get here? Here 4 means we can write 100. Okay, we require 3 bits. We use 3 bits to represent. So it is a -4. Here how many bits we use? 8 bits. So simply we can write, these are the 8 bits. Understood? So we get +4. I hope you understood this. Clear? Understood? For example, if I write, so this is a -4. -4. Okay. So now if I write like this, so now it become -4. So how do I represent -4? For example, here -4 100. How do I represent -4 in 8 bits? Just I'll extend this sign bit. This is the representation. I hope you understood, everyone. Thank you. So by this example, we conclude, okay, the S represent only the given number is negative. The S does not make the number is negative. I hope you understand how to represent a constant numbers in Verilog, the two in sized or unsized form, and also signed and unsigned numbers. Thank you very much.